So this video is meant to demonstrate how to do concept modeling in SysML. This is going to pick a very simple kind of problem space, but it's going to touch on the kind of abstract level modeling that I would normally expect someone to be doing when they're doing concept modeling. I'm happy to be using Astah SysML, and I've picked a problem space here. This is activity modeling example file. The basic domain we're talking about is entertaining at home, and in particular we're going to be talking about a home kind of dinner party. This is how I normally organize my SysML models when I know that it's going to be a small model that only a small number of people are going to be working on, or just myself. It just makes it easier to keep track of where all the basic parts are. I like to separate my requirements, my use cases, my behavior, my structure, the engineering analysis that I use for parametric analysis, and then the value types, which you have to have if you're going to do any type of analysis. But I also keep my item types, in other words, the things that are actually flowing around the system or on my model, in a separate place. And you'll see why that's useful, hopefully, by the time this is done. I'll start digging through here, talking about a little bit about how I go through doing top-level concept modeling. We're assuming that we start with some sort of mission statement, and that mission statement could come from the customer, or it could be something that we draft to describe the mission that we're trying to perform. And in this case, I'm just going to go ahead and open up a requirements diagram that has a number of requirements on them already, including the mission statement. The requirement here, I just call it hospitality, and then basically I'll read it here. A household wants to exercise their hospitality towards their network of family, friends, and associates in a domestic kind of situation, and for a number of reasons, and their motivations are usually very important to include in some sort of a mission statement when you outline your stakeholders. By thinking about that mission statement enough, you get to the point to recognize that there are probably additional requirements that really need to be elaborated. And so there's I like to separate the mission statement, which can be fairly large and complex and may even have a hierarchy of its own. You might break the individual requirements out with a composition kind of relationship. I like to separate that from mission requirements, which are slightly derivative, and add a little bit more assumptions or context to that mission statement. In this case, here's a mission requirement that says individual members of the household will want to be able to host parties for their guests. Well, brings out a whole nother derivative, not really a derivative requirement, it's an embedded requirement that talks about what is a guest. Guests need to be able to be invited to parties, and that's really contained within this mission requirement MRO1. So because it's a composition relationship, I've actually sub-indented it MRO101. I also have come up with a couple of derived requirements, and I could have a better rationale for these, but basically that the parties will be conducted at the house in which the household resides, and they will usually incorporate the idea of serving food to the guests. That sets the stage for wanting to have a dinner party. Okay, so those are the kind of ways of treating requirements in a very simplified sense. Now, you can debate any of these. The fact that you may want to debate some of these requirements is actually a good thing. It means that I'm actually engaging your imagination. And so with that set of requirements understood, let's start talking about some of the use cases that we might want to have here. First of all, we need to understand our stakeholders, our actors. We talked about household members and the requirements. We talked that there's an idea of a hosting, one of the household members choosing to host a party, one or more guests being engaged in a party. There are some other things that will come out later as we start doing some elaboration of the kind of scenarios that might be involved in holding a dinner party. I've listed a whole number of various potential use cases here. Not all of them made on the use case diagram. To be frank, I'm not sure where to put them, and so that's one of the things that we need to work through when you're doing this sort of conceptual analysis. I focused initially on this idea of a dinner party, but there's an extension of that that would be a holiday party, which is kind of a dinner party but in a slightly different context because there's usually a theme or a set menu or something like that. But it's really kind of an extension of a dinner party. Then I have this thing up here. There's another kind of party that really is a different scope, and that is a family reunion, which may have more or maybe fewer guests, but with a different type of context. It may be related, it may not. That's something that has yet to be determined. We'd probably have to go through some discussion with some of the stakeholders to make sure that they understood that. I am using Astah SysML version 1.3, and while it handles the idea of use cases pretty well, it doesn't really handle the context of a subject. I had to use the shape menu to put a box on here. There it is. In that box, I called it party. You'll see later that I actually created a block called party because we need to be able to refer to it. But I wanted to be able to say there is something about a party which is different than other kind of events that might be hosted at the house that would involve maybe other kinds of people, like hosting a Cub Scout Den meeting, for example, that being different. So with that said, now we have starting to have an understanding of what it means to hold a dinner party in terms of what all the actors are involved. What we really ought to be able to do very explicitly is go back to our requirements and then write a goal statement. The host has a goal that is when they initiate holding a dinner party, right? And that goal could be multifaceted. And I think we go back to our initial mission statement requirement, we could easily extract something that would be an appropriate goal that would make sense. Now, the real reason I wanted to dig into this is I want to lay the foundation for doing some activity modeling that's going to elaborate this idea of holding the dinner party. But before I do that, I also want to make sure that we have our terminology straight. So a lot of the terms that we will be using in building the activity models are already on this page. But it sometimes makes sense to actually start to build a little context model. And the context model can now put on one page in a little bit more detail the kind of terms that we're going to be using. And so what I did here is I built a very simple BDD, block definition diagram, that now can start to show some of the relationships that are going to be important to recognize as we start going through the activity modeling of what actually happens in terms of preparing for and executing a dinner party. Well, there's a couple of concepts here: the concept of the house, the concept of a grocery store, the concept of food. The guests come to the house. These are associations I put in and actually labeled. And this is actually a pretty cool thing to do in Astah. All I really had to do here is draw a association and then start typing in the name field, and it immediately recognized the direction that the association was in and put the arrows in automatically, which is kind of a cool feature. So that's one thing, one way of looking at it, and that's a kind of fairly abstract, simplistic way of looking at it. What I wanted to be able to do that maybe is to get to the point where I could draw an internal block diagram. In this case, it's probably not necessary because of it's just so simple and fairly easy to understand. But here is where I introduce the concept of a party. This is a different block definition diagram using many of the same elements. And here I'm showing a party has several reference properties. The reason the reference properties are important, it basically says, well, when the party's over, the house doesn't go away, the host or the guest doesn't go away, the grocery store doesn't go away, but by gosh, the food probably is gone, right? And so the food there is a component. It's a composition relationship as opposed to a reference relationship for these others. And I still have this association that the grocery store is a source of food, which is going to be important later. And we can elaborate this a little bit more. There is a danger in over-elaborating this and putting too much stuff on it and then making it confusing. What you want to do is just have enough on here that you can start to describe some of the behavior. With that said, though, I want to just go one further. Sometimes, in order to make things clear, it's useful to build a internal block diagram. And so I tried to do that, and then I quickly realized that that's really not adding a lot of value. And so with that in mind, I'm perfectly happy with just actually this first context diagram on the VDD was enough for this simple example. That gives us some vocabulary now that we can relate to, and we want to start laying out our activity model. So what I've done is I've taken this whole dinner party use case and I said, well, let's start to elaborate that. I want to build an activity model of what it means to hold a dinner party. I've already, now what I've done here in Astah, one of the things, the restrictions they have is they don't have an activity as a first class model element. What they do have is the activity diagram itself, which represents the activity. You know, the activity diagram frame actually represents an activity. You can take an activity diagram and drag it onto another activity diagram, and it creates this call behavior action, which ends up calling that that activity diagram. So in a way, activity diagram is acting like an activity would in another tool, or what an activity should act like in a UML or SysML tool. But in this case, you don't see the activity itself. All you see is the diagram. And as a result, you really don't have the ability to segregate definition and usage and put in action names the way that you probably could, or you can in other tools. But what I will do here is I've already created a number of different activity diagrams, or activities, if you will, that are germane to holding a dinner party. And what I want to do here is start sorting out, well, what order do these have to happen in? And if I missed one, then we'll create one. So what I'll do first, I'll put a start node in. Okay, that's where we're going to start. And the first thing I think I'm going to want to do is create an invite list. Okay, then I'll just do this. What I want to do first is have a single thread that kind of starts to make sense on, you know, what are the things that have to happen to get this dinner party going. So I need to send some invitations. I need to buy some food, which I want to do before the guests arrive. Then I want to receive the guests, and then I want to serve the food, and then provide entertainment in that order. Okay, which kind of makes sense. Now, while I'm doing this, I could have one of my clients in the room, or the customer who's going to be accepting, you know, my model or my specification that I'm building here, and so by starting in this simple way, I've got something that I can get some dialogue started with very quickly. And I know that it may not be exactly right, but that's okay. It's at least a place to get started, and can say, well, is this really the order that you want to have things happen in? And they can say, yeah, it is, and if it's not, then we can debate about that, and get some more clarification. But what I'm doing right now is I'm creating control flows with the dashed lines to show that this is all control flow, which basically says this is the sequence in which things have to happen. Now, so what we're left with here is a perfectly legitimate activity diagram, but not one that's very interesting. Okay. What I want to be able to do is start to ask the question of my customers or clients or users, and my engineers for that matter, why does that have to happen in this order? Is there something that the following action is depending on that comes out of the preceding action? Well, it turns out there is. For instance, it looks like actually that we've actually missed a particular action. So what I'm going to do is I actually have to create a new activity diagram, because we didn't put in here that we were actually going to cook the food. So that's what I'm going to do now. We can't just serve the food raw, so I'm going to say that we have to cook the food. Okay. And if I go back into my dinner party, I say, well, I got to cook the food, all right? So I'm going to now move things, excuse me. I'm now going to move some things around. I'm going to say that I'm going to be cooking the food first before I serve it. But in this case, I'm going to be cook the food before I receive the guests. Oh, you might think that's a good idea. There we go. Now, as I said, what I wanted to be able to do is say, what are the dependencies? Why is it done in that particular order? Well, certainly buying the food, cooking the food, and serving the food has to happen in that particular order, because there's food involved, and the food can only be in one state at a time. So what I have done here, and this is a kind of a handy thing to do, I've created an item type here called food, and I'm going to go ahead and use that here. I'm going to drag it onto my activity diagram, and as I said, I'll drag it onto my activity diagram. There we go. And I'll give it a name. I'll call it raw. The raw food is one that is in the condition when I buy it. So I'm going to use an object flow, which is a solid line, to connect the raw food between buying it and cooking it. And logically, you can see that there's another opportunity here to for being explicit in showing the cooked food. And now you can see that this is using the part name and the type name, block name, as it would in a normal IBD. As I said, because Astah's restriction does not let you do that with the actions, which would be a good idea, but it won't let you do that. So you just have to kind of remember. So after the food is cooked, then it can be served. Come on now. There we go. Okay, so with that said, now we can think a little bit about if there are any other flows that might be important. Well, I'm going to look at one more, and that is before you buy the food, there's another action missing. In fact, the more you look at this, you may say, well, there's some things that you just forgot to do here. Like before you can buy the food, you really need to think about what it is you're going to buy. So you need to prepare a menu, right? So let's add that as a generic behavior in my behavior package here. So I'm going to say I'm going to create a new activity diagram. Come on, baby. Okay, and that one I'm going to call prepare menu. Okay. Then going back to my whole dinner party activity model, I'm going to insert prepare menu. Okay, I'm going to prepare the menu after I've sent the invitations. I can certainly do that. That's certainly allowed. Okay, and I'm going to use I'm going to wire this back into the activity model with a control flow. If the tool will let me do it. There we go. So what I wanted to get to here is the idea that, well, what do I need in order to buy the food? Well, I really need a shopping list. Well, a shopping list is another type of thing, and so I'm going to add a new block in my item types that I'll call list. Okay, because that seems to make sense to me, and I'm going to add list onto my activity model. Maybe. Okay, I'll try it again. I'm going to add list onto my activity model. There we go. And it's going to be a shopping list. Okay, and out of preparing the menu, I will have generated an output of a shopping list that then needs to be used for buying the food. Okay, so now that we start to flesh out where the data flows are, the object flows, the difference here is that the dashed lines are control flow, the solid lines are object flow. This is now starting to make sense in starting to understand the dependencies. What I want to get to is a top-level understanding of what things can happen in parallel, right? So with that in mind, it's clear that I need to create, well, here's another idea. Well, yeah, I've got this invitation list and sending invitations. I have this list already. I'm going to put this list in here again, the idea of a list, and I'm going to call this the invitation list, because that only makes sense. And so I'm going to wire that in with an object flow, and I'm going to use the invitation list as the basis for sending the invitations. I can't send the invitations unless I have the invitation list. Okay. So with that in mind, that's probably enough for now. Let's start to think about what can we do in parallel, and what has to be done in series. So one thing that comes to mind is that I certainly I could have all of the food things kind of happening in parallel, but I really want to have preparing the menu happen first. So I'm going to, so here's what I want to be able to do. I'm going to start by saying, after I've sent the invitations, then I can prepare the menu and buy the food. So what I'm going to go ahead and do here is make some room initially. I'm going to insert a fork, and that fork is going to come after I've sent the invitations. It's not helpful. Having tool problems here. Yes, I know. Go away. Okay. There we go. So I can now say that I can prepare the menu and buy the food. Okay, because of the way I'm doing this, I no longer have to have this relationship. Okay, so what I will do is I'm going to put in a join, so I can bring these together, bring these control flows together. And now I can start to see what kind of real dependencies I have. And that can help me determine how I can do better at doing my dinner parties in the long run. Okay. So now that's still, we're still talking about what happens before the guests arrive, but what I can do here is, and it makes sense to me, is I can say that there are a number of things I can do in parallel when the guests are actually present. And why is it only making my day? Come on, baby. Okay, fine. I'm going to put another fork in here. Okay. Oh, come on. There we go. Nope, still not. There we go. Okay. And now I'm going to say that I can cook the food. I can receive the guests. I can cook the food. I can serve the food. And I can provide entertainment all at the same, all in parallel. Because I'm the kind of person who, I like to have my guests kind of with me in the kitchen while I'm preparing food. And, we may actually have some entertainment going on in the course of actually doing the cooking. So to model that, I would have to say that that I would want to be able to show these things happening in as much a parallel kind of way as possible. So providing entertainment out here, and I'll show that joining together. Okay, now I appreciate that the lines look a little bit messy. And if I had time, I would go ahead and clean those up for you. Maybe in the final version of this model, as I finish it, I will and post it. I will do that. But in the meantime, I'm just trying to get enough going here that I can show you that this idea works. And now I have to make sure this cook food gets connected as well. That's wrong. Let's see if I can make this work. It's a tough one. Let me move this down. There we go. Fine. Okay, and let me see if I can get this one to work. Because I really need to have a control flow. I need to have it get down to there, and I'll show the final note at the bottom. So what I've tried to do here is show an activity model that incorporates both control flow and object flow. It's a way of establishing a dialogue with stakeholders about, well, what is really happening and what order does it have to happen in, and why does it have to happen in that order. And it's not necessarily, it's not necessary that this diagram be totally accurate in order to be useful. The main thing is that it gets the dialogue going. At least it doesn't have to be accurate right out of the box. Hopefully, as you are discussing this with your stakeholders and talking about, well, why do things have to happen in certain orders, or you have domain experts that know all about how to do things like dinner parties, they can explain to you, well, there are different ways to do it. You can look at different more innovative approaches. The SysML principles I'm showing here are actions based on call behavior actions or calling activities, which have underneath them can have their own activity diagrams, which is starting to build in hierarchy. I've shown the concept of forks and joins. We didn't show decision nodes, but that's another thing that could be put in if we want to show some logic or some iteration. I did show the idea of object nodes. I did not show the idea of pins. The object, the activities, the actions themselves can have action pins. Those action pins then can be the source and sink for various object flows. I've just showed in a very simple way here, which is fine at the concept level, but when you get into advanced activity modeling, or to the point where you want to start allocating behaviors, trying to take these particular actions and the respective activities and allocating them to other parts of the system to actually go, do your functional allocation, you really do need to get down to having pins rather than these object nodes. Anyway, that's what I've got for now. I hope it was instructive. How to build a concept model that includes use cases, requirements, a domain or concept model, as well as elaborating a use case with a concept level activity diagram. Thanks a lot for listening.